Welcome to lesson 2.5. We are going to continue graphing, but today we are going to look at something a little different. We are going to look at how to graph absolute value functions. So an absolute value function is going to be given in this form. Just fair warning, the function that I'm giving you with these letters, these variables, M, A, B, and C, these are going to look a little different than what your textbook says. I have my reasons for it, and we'll talk about that more later. But for now, I want us to remember M, A, B, C, and then we do still have an X here. So the vertex of an absolute value function is either the minimum or the maximum. And an absolute value function is going to look like a V. So your vertex is either going to be this point at the minimum, or it can open downward, and the vertex is the maximum. And it's given by this C. So we're going to use these values, and that negative in the formula, change the sign. Let's do a few practice problems and see how this goes. So if we're given this problem and told to graph the absolute value function, the first thing that we want to do is find the vertex. So to find the vertex, I'm going to start first by labeling all the different points. I always put M, A, B, C in there, even if some of those values aren't written. So for example, M, there's no M written, that means it's a 1. Because it's being multiplied. Let's see, nothing's being added onto the end, so it's a 0. So when I find my vertex, I'm going to do negative B over A, comma C. And we're going to get negative 12 over 4, and then our C value is 0. But 12 over 4 can simplify, and that's going to give us negative 3, 0. When I graph that point, I'm going to go left 3 and up 0. And that's our point for the vertex. So the next step is to there we go. It's to substitute in values for x. We're going to make a table of values, and you have to have 5 points on your graph. 5 points. There we go, 5. And we're going to do this by picking values that are to the left of x over here, or to the right of x over here. And I'm going to show you what that looks like. We could pick anything. I could pick negative 8 if I want, but typically I want to pick values that are closer to the vertex. The closer to the vertex they are, the more likely they are to be on the graph and not go off the graph. If I were to plug in negative 8, I would get something that's graphed way up here somewhere that I can't actually put on the graph. So for my left and right values, I'm going to plug 2 to the left. I'm just going to go to the left. Negative 4 and negative 5. For my values to the right, I'm going to plug in negative 2 and negative 1. All right, so plugging in these values, I'm going to continue to use absolute value. All right, so if I plug in negative 4 plus 12 would give me negative 8. I'm not going to spend a whole lot of time going through the evaluating. I'm hoping that we're confident enough at this point that we can just evaluate that without taking too much time. If you need a little extra help, let me know, and I'd be happy to go over it with you. Plugging in negative 5 would give me negative 20 plus 12, which would give me negative 8. Absolute value is positive. So if I graph those 2 points, I'd get negative 4, 4, negative 5, 8. All right. I'd get negative 8 plus 12, which is positive 4. And then plugging in negative 1. I would get positive 8. It is not required to write the ordered pair. I'm just doing that to kind of show you how I'm getting these points. I'm getting that by taking my x value and my y value. You are required, though, to show your table with at least 4 points in it. If you want to put more in there, you can. So negative 2, 4 would go here. Negative 1, 8 go here. And then I'm going to bring this line. Remember, it should make a V, a sharp curve with a short point at the bottom. And that would be an absolute value function. Check whenever you're doing this, it's good to check your rate of change or your slope on both sides. Here, if I were to go from this point to this point, I would have to go up 4 over 1, so just slope up 4. But this one, I would get a slope of negative 4 because I would have to go down 4, down 4, and over 1. So just make sure you're paying attention to using slope the same. Let's look at a little bit challenginger problem. I'm going to start by labeling my values, and then I'm going to find the vertex. So my vertex is going to be negative, and then it's b over a, so negative 2 over 5 halves. And that looks kind of funny to write it that way, but I just want you to see how we're getting all these different things. And then negative 3, I'm going to put the c at the end. So the two negatives are going to make a positive. And when I do 2 times, and that gives me 4/5 comma negative 3. All right, so when I graph 4/5 negative 3, I'm going to go past, not quite to 1, I'm going to go past 0, but then I'm also going to go down 3. Now I get to make my table. And when I'm picking the integers that I want to plug in, I should say you could pick values to plug in for x like 1/2, but I wouldn't recommend it. I would just recommend picking integers. I'm going to look for the first integers that I encounter if I travel from this point directly to the left. And as I go from here to the left, the first points that I cross are 0 and negative 1. So those are the points that I'm going to plug in. And then when I go to the right, the first integers that I encounter are 1 and 2. So those are the points that I'm going to plug in there. All right. So plugging in my formula. Don't forget to include the minus 3 at the end. You have to include the whole formula. And I'm going to just start plugging in. All right, so I did a few of those pretty quickly. And then right underneath, or I had to start recording again. But I would get 5 halves times 1 minus 2 minus 3. And this is going to give me 5 halves. 5 halves minus 2 halves. 1/2 minus 3. I'm going to get negative 5 halves. And then here, I'm going to have to move this work over a bit. The nice thing about dealing with the even numbers is that the pairs cancel out, so I just get 5, and then minus 2 is 3. Minus 3 again would give me 0, so I'm going to get to point 2, 0. And when I graph these, I'm going to have 0, negative 1. I'm going to have negative 1. So 2.5. Now if I connect those lines, and I'm putting the arrows on the ends. This one might look a little weird because over here we saw that there was some symmetry. If I drew a line of symmetry going through the middle, these lines or these points lined up, these points lined up, but here on this one they are not going to line up because this point right here is at 4/5. So that means that our line of symmetry is actually off center from being on a whole number, and it's just going to make things look kind of wonky, I guess. I can still check though and see if these are the same values. If I start from here and get to this point, I'm going up 1, 2.5, and over 1. If I start from this point and move to this point, I'm going up 1, 2.5, and over 1. So even though like there's no mirror image for this point, that's okay because there's still going to be the absolute value function. If I fold it in half along this line here, if I draw that all the way through and then fold it in half, it's still going to match. So we're doing okay. All right, so for this one, see if you can figure out what are your M, A, B, C values, and then try and set up your vertex. All right, so this one's a little weird because of how it's written, so I went ahead and rewrote it so that it was in order. I've got M, A, B. This 6 is being added technically. So I just moved it to the end so that it was in the correct form. 1. And then my B is going to be 0 because nothing was written. So to find the vertex, I'm going to do this case. I'm going to get 0 over 3, which is this going to give me 0. The x coordinate of my vertex, and then 6 for the y coordinate. So I'm going to graph the point 0, 6. And now I can find my other points. I'm going to pick 2 points to the left, 2 points to the right, and I'm going to make a table. My 2 points to the left would be -1 and -2. Again, I could pick values that are further to the left, but they would just be quite a bit further away and not really graphable. I'm going to get -1 and -2. To the right, I'm going to put -2. All right, draw your own table and fill it in. See what values you get for each. All right, so your values should look like this. Your work, you can. I've got the point -1, 3, -1, 3, -2, 0, and then I've got 1, 3, and 2, 0. Now, because my vertex was back on both of the x and the y coordinates were integers instead of over here where one of them was not an integer, because they're both integers, the lines or the points should line up. So if your points didn't match, something went wrong. Again, you can also check the slope here and make sure that your slope of each side of the absolute value function is the same. If I check the slope here, I'm going down 3, left 1. Here I'm going down 3, right 1. So it's the same height, same rise over run, just different directions. So this has been graphing absolute value equations. If you have any questions, please let me know. But really, I think the biggest thing is that this just takes practice and patience, making sure that you are taking the time to make that table completely and check all of your work.